So I wanted to talk a little bit about the projections, and I'm kind of looking at step 33 in the tutorial. So I have ArcMap open and I have two data frames. One data frame uh, shows, let me just zoom to the maximum here, shows the entire world, and I was zooming in on the United States. And I have another data frame, so I'm going to click here. Whoops, I'm going to click there and activate that data frame. And that you see the United States, the different state layers. You can see the shape of the country is really different. So let's go to the layout view for just a second. And you can look at both of these kind of side by side. So I'm going to move the United States up there this way, and then the other data frame shows the United States that way. Alright, so I'm going to move it. So there's a major difference in the shape of the United States based on these two different maps, or these two different data frames. So this data frame, if I go into the properties and into coordinate system, it tells me that the GCS is the geographic coordinate system, and it is a coordinate system that is based purely on latitude and longitude. There's been no projection added or created to redistribute these points to have a more accurate shape or look. And if you close this folder, the country, or the data frame called new data frame, is in this geographic coordinate system. So none of the coordinate systems here are projected. So I'm going to call this, I'm just going to rename this GCS. Okay. And in fact, if I look at the actual data layer itself and look at the source, it will tell me that this data is a geographic coordinate system. It has the datum, or the control system, or the basis of that coordinate system is WGS 1984, and the angular units are in degrees. So that means that with data in this coordinate system, I can't do any accurate linear measurement because everything is in degrees of latitude and longitude. So if I look at this coordinate system in this feature data, or feature data frame, sorry, this one comes up and says, okay, this data frame is in the North America Equidistant Conic. It's a conic projection. And if I scroll up here, I'll see that this information is in the projected coordinate system folder. And in the front of your textbook, I'm going to go ahead and open that again, and I closed everything, so let's go back and open that. Oh, it's North America Equidistant Conic. So if I look at the Equidistant Conic in the front of your textbook, it says that this is good for regional mapping of east-west oriented areas. So the United States is wider east-west than it is long, tall, north-south, and so this is a good projection for that area. if you look above that in the textbook, it says the geographic projection is the geographic coordinate system is unprojected. So you see a real difference in this data. Now, data frames, so I'm going to insert a new data frame, and what that lets me do is create a third map if I want. So I'm going to just go ahead and scroll all these a little down here, and when I add a new data frame and I look at the properties, there is no coordinate system. So the data frame will take on the coordinate system of the first data layer that you add. So let's go add something. Let's see, I'm already connected to the MGIS folder. Let's put something in, I don't know, we've got Oregon. Well, let's put something in Oregon. Let's see if we have a state or counties. We have counties. Okay, I'm going to add that. Okay, so there's the Oregon counties. And if you look now, Oregon is oriented. I'm going to go ahead and move this down so you can see Oregon here. Oh, maybe I'm not. Let me get my layout tool. I'm going to dock it here. Okay, so there's my pan. Okay. Oh, come on. Really? There we go. All right. So in this coordinate system, which is the, what did I say, that equidistant conic? I'm just going to call it. Or not. I'm going to name that layer. Sorry. Equidistant conic. So I've got this layer, and you can see that Oregon is rotated a little bit. Oh, the phone's ringing, so hold on a second. Okay, so where was I? All right, so you can see that Oregon is rotated with this conic projection. The focus of this projection is the middle of the country. Let's take a look here again at the properties, and it will tell you that the central meridian is at minus 93 degrees, which is somewhere around here. So the center of that projection, the states that are going to point more directly vertical, is in the middle of that. Oregon, this projection, so remember this had no projection because we didn't have any data in that data frame. Now when I turn on the properties here, it says that Oregon is a specific coordinate system called the Lambert conformal conic. This is also a conic projection, but the standard, the meridian, is at negative 125 or negative 120 degrees longitude, and that's kind of in that part of Oregon. So the data frame then takes on the projection. Now what's really interesting is that if I grab, I'm going to go into here, if I grab the states layer and pull it down into this, the states layer now takes on the projection of the data frame. So even though this data is officially in a North American equidistant conic, when I put it in a data frame that has a different projection, ArcMap will project this on the fly. I can do the same with country. I can pull it down here, and this one gives me a warning. It says, wait a minute, these are different coordinate systems, and I'm going to let ArcGIS do its thing. If I turn, let's go back to the data view, and I want to make this data frame the active data frame. So I'm looking at Oregon, which is now projected kind of north-south. I'm looking at the state layer that is originally a equidistant conic, which has now rotated that to line up, and it's also taken the country layer, and rotated that to have to line up. So I can take the country layer here and put it in there. I'm going to make this one active. And now ArcGIS has projected the country layer on the fly to make it look like the state layer. Okay. Now the actual projection has not changed. It's still an unprojected layer, but it's in a projected data frame so that all of these are made to line up.